So today we are going to be solving equations using our exponent laws. If you paid attention to the titles of all of the rest of the lessons in this unit, we were solving expressions or simplifying expressions. Today's equations. What is the difference between an expression and an equation? Yes. Sam, can you say it louder for everyone to hear?
An equation has an equal sign.
Okay, did you hear him? That's the difference between an expression and an equation. So if you look at your notes today, all of our problems have equal signs. Two things equal to each other, okay? So we're going to do the front side today, and the back side I think we're doing on Monday, okay? Tuesday will be practice, and this worksheet is our last lessons of the unit, okay? So is that an extra? Just hold on to it for now. So once we finish this worksheet, we're not doing any more new lessons, and we'll just be reviewing for the test, okay? Yes. This will be on the test, yes, because the test is in 2 weeks. So it's not when? No, there's like a mini assessment tomorrow with like more like a quiz, but our test isn't until February 12th, I think. Okay, not February 30th. It's a leap year, but that day does not exist. So here are our first two examples. Can you guys tell me what are some things that you notice about these two questions? There's equal signs, yes, so that's how we know they're equations. There are some radicals, yes. There are some fractions in my exponents. What'd you say? One of them doesn't have a root. What'd you say, Nathaniel? 5 is the what? Yeah, 5 is one of my roots. Do you notice anything about the bases? The bases. They are the same. Okay, remember yesterday Diego asked me, will I ever give you a problem where the bases are different? Do you remember what I told him? I said no. However, that is only a partial truth. If I give you something where the bases are different, it'll be in a way that you can make them look the same. So if I give you like 2 and 8, I can make 8 have a base of 2. Does that make sense? I can write 8 as 2 cubed. I won't, like I said yesterday, I won't ever give you 2 and 3 or 5 and 7 or anything that's not like that. So for this lesson, it's important that you notice that the bases are the same. Don't die, please. Okay, the bases are exactly the same, which is what allows us to solve these problems. So on number 1, I have a radical, and I want to turn it into exponential form to solve. So I have 4 to the 1/7 power, and remember from yesterday, I put this in parentheses, okay? How do I turn that radical into exponential form? What is the new exponent on it? It's what over what? I heard a couple of you. 1 over 5. Good. Okay. And this equals 4 to the 1 over x. Is that okay so far? I haven't really done anything. I've just rewritten the form. Okay. So, what do I do with the 1/7 and the 1/5? Yes, I multiply them. Remember, this is the power rule. So when I have a power to a power, I'm multiplying them together. So my base stays the same. What is 1 times 1? 1, good. And what is 7 times 5? 35, perfect. And then the right side, I haven't done anything with it. I just keep bringing it down. Okay. Now, once again, my bases are the same, aren't they? Okay. So that means I can just rewrite the exponents equal to each other. How can I solve for x? I can cross multiply, so let's try that. I get x times 1 equals 35 times 1. So what does x equal? 35, good. And sometimes I don't have to cross multiply. That is mathematically and algebraically correct, but if I look, do you see how my numerators are the same? That means 1 equals 1. Then what must x equal? 35, and that's what I got when I cross multiplied it. So x equals 35 is my answer. Okay, number 2 is the same idea as number 1. Yes, I'm going to put parentheses around the 2 to the 4/3. Okay. And what's my new exponent going to be? 1 over 2. Good. And this equals 2 to the x divided by 3. What do I do with those exponents? Perfect. I'm going to multiply. So I get 2 to the what power? 4 over 6. And again, my bases are the same. So I have 4/6 equals x over 3. I can cross multiply, so I get 12 equals 6x. And what is that? I divide by 6, and I get x equals 2. Now, if I didn't want to cross multiply, let's come back up to this step. And if you cross multiply, go right ahead. That's perfectly fine. If I look right here, can I simplify 4 and 6? Yes, I can divide each by 2. Good. And I get 2 over 3 equals x over 3. So what would x have to be since the denominators are the same? X is 2, which is what I got when I cross multiplied, okay? Is that okay so far? 3 and 4. Number 3 and 4. What do we notice about 3 and 4 compared to 1 and 2? There's 2 radicals. Good. But what do you think we do? Still the same thing. Okay. So, instead of putting 8 to the 5th power inside my parentheses, I'm going to write 8. Okay. What is my power? 5. So 5 goes up top. And then what is my root? 3. So that goes on bottom. And that way I've already solved for it. Is it wrong to write 8 to the 5th and raise that to the 1/3 power? No, because I'll get the same exact thing when I multiply across. But it's a little bit of a shorter way to write, just write 8 to the 5/3 from the beginning. Okay. Times, what do I have? 8 to the what power? 6 over 3. Good. And that's equal to 8 to the x divided by 3. Okay. What do I do on the left side? What do I do to those exponents? I multiply them? I add them. Good. And what is 5 plus 6? 11 over 3. And since I have the same base, I can just write 11 over 3. Whoops. Equals x over 3. So what does x equal? Equals 11. Perfect. Number 4, we're going to do the same thing. I have 16 to the what power? 16 to the 7/6 times 16 to the what? 8 over 6. Good. Equals 16 to the x over 2. Now, can I simplify 8 over 6? Yes. Do I want to? No. Why not? Correct. Good. They won't have the same denominator, and I know I need to add them. So I have 16 to the 7/6 plus 8/6 equals 16 to the x over 2. Now, what is 7 plus 8? Good. I have 15 over 6 equals, 16 to the x over 2. So 15 divided by 6 equals x over 2. Can I cross multiply these? Yeah. And then I would divide. But can I also simplify one of the fractions? Yes. I divide by 3. And I get 5 over 2 equals x over 2. So what does x equal? Perfect. Is that okay so far? So number 5, 6, and 7. What do we notice about these ones that might be different from the previous 4? What'd you say? Yeah, some of them are missing a denominator. In most of the other cases, it was a numerator. What else do we notice? Yeah, they're equal to a radical this time, so maybe it's flipped. What about 6 and 7? Those are fractions, okay? So before I was multiplying, when I multiply, what do I do to the exponents? When I use the product rule, yes. What do I do to the exponents? Add them. So on 6 and 7, what do I do to those exponents? Subtract them. Do you all know that? This will be on like your test for sure. Okay. Number 5. I have 2, and since the base is the same, I'm automatically going to add the exponents. I have 2 to the 7/3 plus 5 over x equals 2 to the what power? 12/3. Okay. Now, since the base is the same, I'm going to set the exponents equal to each other. Okay, so there are 2 ways to do this kind of problem. One way is like more of an algebraic way, and the second way is more of an intuitive way. I'll show you both ways, and you can decide which one you prefer. Okay, so the first way I'm going to do it is I want to get the 5 over x alone, because that's where my variable is. So I'm just going to do a multi-step equation. I'm going to subtract 7/3, and I'm subtracting 7/3. Do you know why I'm subtracting 7/3? To get the x by itself. And yes, Helene, they do happen to have the same denominator. So what is 12/3 minus 7/3? What is 12 minus 7? 5. So that means I have 5/3 equals, and then I still have the 5 divided by x. So what does x equal in that case? 3. Good. Okay. Now the other way I can do it is if I look back at the question before solving anything. What is 7 plus 5? 12. Is that what I have right here? Yes, so let's look at the denominators. They all need to be exactly the same. I have 3x and 3, so what does the x have to be? It also has to be a 3, so that's how I got x equals 3. Okay, so that's a little bit of a shortcut. Okay, number 6. What do I do to those exponents? If I'm dividing, what do I do to the exponents? Subtract. 4 to the what power? 3. What's the power? 3 over what? 3 over 3. Okay, good. Since the base is the same, I have 4/3 minus 1 over x equals 3 over 3. If I'm doing this algebraically, subtract 4/3. Subtract 4/3. What is 3 minus 4? What is 3 minus 4? -1, and my denominator is 3. And over here, I'm left with a -1 over x. So then what does x equal? 3. Good. And if I look up at the top, I see the same thing. 4 minus 1 is in fact 3. So my denominators all need to be the same. So that means x is still 3. This one okay too? Okay. I'm going to do number 7, and then you'll have just under 10 minutes for the U-tries. So for number 7, what do I do to the exponents? Add, subtract, or multiply? Subtract. I have 9/4 minus 1 over x equals 3 to the what power? 4 over 2. So I have 9 over 4 minus 1 over x equals 4 over 2. So I'm going to copy this and put it up in the middle so I have some more space. Okay. If I'm subtracting 9/4, Can I subtract 4 halves and 9 fourths as is, like that? No, I have to give them a common denominator. So what is their common denominator? It is 4, so I'm going to multiply by 2 and by 2. So 4 times 2 is 8 over 4 minus 9 over 4 equals negative 1 over x. So negative 1 over x equals negative 1 over 4. So x equals 4. If I did that algebraically, I could see the same thing. 9 minus 1 is 8, but what I have is 4. But in the denominators, they're also different. So if I multiplied by 2 and by 2, well, then I would have 8 over 4. 9 minus 1 is, in fact, 8, and then all of my denominators are 4, which means x is also 4. Okay, you have 8 minutes. Please get started on the U-tries. Those are the last 6 on the front page.